Hello everyone, I am Chirai Vibhute and today I am here to explain the topic of displacement and velocity. In today's video lecture, we will be discussing what is the actual meaning of these two terms, how are these two terms same yet slightly different from their scalar counterparts, that is speed and distance, and thirdly how to calculate each of these. Now let us start with some basics. As we all know that speed is distance upon time, that is how much distance you have actually traveled per unit time. That unit of time may be per hour, per second, per minute, whatever you want to take. Okay. Now you can see that I have drawn a diagram here. It is a line which has 3 points A, B and C. The distance between A and B is 20 meter. The distance between B and C is 10 meter. And just like any number line or the x-axis of any graph, let us consider the rightward direction as the positive direction and the leftward direction as the negative direction. Now suppose an object is traveling on this line. It travels from A to B, then it travels from B to C, and then it travels back from C to B. Okay. So can you tell me the total distance traveled by the object? It is very easy. AB 20 meter plus BC 10 meter plus CB again 10 meter is equal to 40 meters. Now suppose the time taken by the object to travel from A to B is T1, that is 10 seconds, B to C is T2, that again 10 seconds, and C to B is T3, again 5 seconds. We have taken this as assumption, okay, for the example purpose. So the total time taken by the object to complete its journey is T1 plus T2 plus T3, that is 10 plus 10 plus 5 is equal to 25 seconds. Okay, now we can very easily calculate the speed of that object. What is the speed's formula? Total distance upon total time. Total distance is 40 meters, total time taken is 25 seconds. So it will be 40 upon 25. It will be 1.8 meters per second. So the speed of the object will be 1.8 meters per second. Now, while we were calculating the distance, at any point did we bother in which direction the object was moving? No, we did not bother. We just added, that is, we just summed up its distance from part to part, that is, we summed up 20 plus again summed up 10 plus again added 10 to it, and that's how we got our total distance is equal to 40. So I want to mention here that such quantities in which only the magnitude of that quantity plays the important role or is of importance, such quantities are the scalar quantities. Okay. And again, there are another type of quantities that are vector quantities. Vector quantities are the quantities in which, along with the magnitude of that quantity, its direction is also to be taken into account. Displacement and velocity are two such vector quantities, and its scalar counterparts are distance and speed. Okay, so how to calculate what is displacement exactly, how to calculate it, and what is velocity, we will try to understand it with this same example. Same example, object travels from A to B, B to C, C to B again. But this time, let us try to take the direction of that object into account and try to find the total displacement of the object. So, already I told you that the rightward direction is the positive direction. The displacement between A to B traveled by the that is done by the object is plus 20 meter. The displacement of the object from B to C, again rightward, plus 10 meter. The displacement of the object from C to B leftward, this time it will be minus 10 meter. So what will be the total displacement? The algebraic sum of all the displacements, that is 20 plus 10 minus 10. So the total displacement will be 20 meters. Okay, total time we have already calculated 25 seconds. So as I already said that velocity is the vector counterpart of the speed. So same formula, average velocity is equal to displacement upon time. You can see the analogy between these two formulas. Speed is equal to distance upon time, velocity is equal to displacement upon time. Total displacement 20 meter, total time 25 seconds. When you calculate it, you will get the answer 0.8 meter per second. But now let us try to calculate the velocity of that object part wise. That is, I want to calculate its velocity from A to B separately, B to C separately, C to B back again separately. So let us term it as v1, that is velocity from A to B. v1 displacement from A to B is d1, time taken is t1. So displacement is 20 meter. 20 divided by t1, that is 10. So velocity from A to B was 2 meters per second, 20 by 10. Again velocity from B to C was d2 by t2, d2 was 10, t2 was again 10. So v2 is equal to 1 meters per second. And the velocity back from C to B will be d3 by t3. Here d3 was minus 10 because it was leftward, and t3 was 5. So it was minus 10 by 5 is equal to minus 2 meters per second. So the partwise velocity was plus 2, plus 1 and minus 2 meters per second respectively. Now let us try to calculate the average velocity of that object from these part-wise velocities. For that, what you do? You do the time-weighted average of the velocity. What is time-weighted average? Here I have written this formula. Velocity, that part-wise velocity multiplied by the time for which that velocity was maintained, its summation, its total sum divided by the total time of the journey. Okay, so simply v1 t1 plus v2 t2 plus v3 t3 divided by t1 plus t2 plus t3. So what was v1? 2. What was t1? 10. What was v2? 1. What was t2? 10. And what was v3? Minus 2. And what was t3? 5 divided by 10 plus 10 plus 5. This in the denominator it is time. When you calculate this is the time weighted average by the way, and when you calculate this, you will get the average velocity as 0.8 meters per second. So it is a good way to cross check if your average velocity that you calculated was correct or not. I hope what is displacement, what is velocity, it is cleared up till now. Okay. Now to sum up today's video lecture, let me highlight some of the observations that we got through the example that we solved. Okay, so I have prepared two parts: distance and speed, displacement and velocity. First of all, the total distance that we calculated was 40 meters, and the total displacement that we calculated was 20 meters. Also, the average speed that we calculated was 1.8 meters per second, and the average velocity that we calculated was 0.8 meters per second. So, what do you observe by this? We can infer that distance will always be greater than or equal to displacement no matter what. Displacement cannot be greater than distance. It is a very important point. Same goes for speed. Speed will always be greater than or equal to velocity. Velocity can never be greater than speed. Also, when displacement is equal to distance, then velocity will be equal to speed. That's all. Again, distance is how much you have actually traveled. Displacement is the shortest distance between the points, or the change in the position of the object, or the final position of the object minus the initial position of the object. These are the definitions of displacement. You may want to note it down. Again, the lastly, distance and speed are the scalar quantities, that is, the direction of these quantities is not taken into account, while displacement and velocity are the vector quantities. In this, along with the magnitude, the direction of these quantities plays a very important role. So I hope that you have gotten a glimpse of what displacement and velocity is, and from today you will be able to differentiate them from speed and distance. And that is all from my side for today. Thank you very much.